Okay, here we go. 3.3, we are doing similar, and there's a lot of notes, figures and scale models. Similar figures and scale modals. All right. Now today you definitely need to stay awake. I know. Okay, that's not my problem. Do you see a Keurig back here? No. If y'all want to buy one and we stick it back there.
That would actually be pretty cool. I mean, that would actually.
The only problem with that is when I smell, like, I don't drink coffee, but when I smell it, it, like, relaxes me too much. Like, I might fall asleep, especially if it's, like, dark. And you know how you hear rain, sometimes, and thunder, and then we smell coffee? Forget about it. I'm gone. I'm, like, just gone.
But that would be, like, actually really nice.
Why don't you drink coffee?
It's like a candle.
I'm just not, I don't know. I drink something. But anyway, it's got coffee in it. But, okay, let's go. All right. Similar figures. I drink iced coffee.
Me too. That's the good kind.
No.
Yeah. I like
Iced tea is good.
Pure black
coffee.
Well, no, I drink tea every morning. That's my caffeine. All right, similar figures. You need to know what similar figures are. This is important. They have the same shape, but not the same size. Same shape, but not the same size. Look on page 105. No, but there's pictures of it.
You said page 105?
Page 105. Look on page 105, you will see pictures of similar figures. The same size, same shape, but not the same size. Something I want to add here. They don't have the same size, but what about their angles?
They do have the same angles.
Same angels. Because the size of those angles do not change. 45 degrees is 45 degrees, whether it's on a big figure or a little figure, it's always 45 degrees. You can take a protractor and check all the angles of actual similar figures, and you will see that the angles do not change. So they could be a big and small shaped object, but if they're true similar figures, they will have the same shape, not the same size, like the line segment portion, the edges or whatever, but they will have the same angles. Okay. You also need to know similar polygons. By definition. Polygons in which corresponding angles are congruent. What does congruent mean?
The exact same?
Or equal.
Oh, okay.
and corresponding sides are proportional. I'm setting us up for what you're doing today.
You're setting us up.
So proportional, what does that look like?
A fraction.
Two fractions with a
Equals.
equal. And how do you solve them? Cross multiply. Okay, so that tells you right there we're going to be doing some cross multiplying. Okay, so these two go together. These two go together. Now I'm going to talk about the property of proportions. Proportions. In a proportion, if you can't see in the back, you need to move forward. The product of the extremes equals the product. What does product mean?
The answer of a
Yep.
multiplication problem.
Very good. Product, answer to multiplication of the means. In a proportion, the product of the extremes equals the product of the means. Blah, 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 cross multiply. All that you just wrote means cross multiply. Why they didn't just say cross multiply, I don't know. Any questions so far? When you're done, put your pencil down so that I know that you're done. Okay. I want y'all to pay very close attention to how we do this example. Pay very close attention. I want you to open up your book and find example 1 on page 106. And even though it's in your book, we're doing it together. So even though it's in your book, we're doing it together. It's a great example, but I'm going to explain it as we do it. Emily, you are my person of the week. Can you please go and erase the portion of the earth science that is sticking out into the screen, please? Allie's. Yeah, you can erase that part too. When we're done, I'm going to tell you Allie is in her engineering class right now, and she's, in school, and she's been blowing up my phone with stuff that she's witnessing right now in class. There's y'all need to be prepared when y'all go to college for some weirdos in your classes. Okay, and we'll
Is it
discuss that right now. I mean, we'll discuss it later.
Is it online?
No, this class is not. She's in person, and there's some interesting characters in her class. Sometimes she'll record them or take pictures and send them to me. I will later. Okay, so let's look at page 106.
Is that illegal?
No.
No, not showing YouTube. She's showing us.
And yeah, we're not putting it on social media or anything. You know, we're not making fun of them on social media. Okay, so example 1 on page 106. I need y'all to look at that. It says find XY given the measurements of the two similar angles. So you're going to do this too. You're not going to just look at that and try to figure it out. We're doing this too. I'm going to draw the two figures. You're going to as well. I'm going to attempt it. If it's not exact, it's okay. Yeah, that's really not exact. This is the bigger one. Okay, that's terrible.
That's pretty good
I don't know.
compared to mine.
Okay, and they give you X, Z, Y, and this side is 2.5. This triangle is supposed to be much smaller than this. Okay, so just bear with me. Do y'all understand what I'm doing here? Okay, good.
It's half as big.
I know. And then there's M. That side is M, and this side is 2.5. Okay, now I have triangle A, B, C, and they say that this side is 5, and this side is 5.7. Okay, they want you to find side X, Y. Okay, so write that down. We're going to talk about this. It's real easy to sit and look at the examples, but sometimes looking at the examples is hard to understand what they're doing. So I, long time ago, decided I'm doing it my way. So, first of all, these are similar because it says similar triangles. So, if it's similar triangles, angle Z would be congruent with what other angle? Raise your hand. Aiden? C. Does everyone see that?
See.
Okay. Angle X is congruent with what angle, Michael?
A.
Very good, Michael. And angle Y. Notice that my lines are different for each one. Angle Y is congruent with what angle, Emily? Very good, Emily. Okay. We don't know the measurements of these angles, but we don't know if they're the same. By looking at them, you can tell they're not, but we know that these two angles are the same, these two angles are the same, and these two angles are the same. I do different lines for each so that we know which is going with each. If you make a practice of doing this, it will help you out. Trust me on that. Okay, so they want to know what is the measurement for X, Y, and they called it M. We don't know what M is. We know this side, and we know this side that goes with that side, but that's it. So, we are going to be setting up a proportion. Y'all did some of this like last year. Okay, so we're going to set up a proportion. It looks like two fractions with an equal sign. Now, the first ratio should be, if you remember from last year, we're comparing. So it should be the sides or the angle, whatever they're looking for, of stuff they've already given you. These two sides here and here, they already gave you, right, Michaela? Right? Okay, so I'm going to compare those two sides. I have XZ, or ZX, however you want to say it. I'm going to have XZ. That is your small one. And then on the bottom, I'm going to put AC. That's my large. So, do y'all see where I'm going so far with this? My first ratio, I'm putting the small on top and the large on the bottom. You could put the large on top and the small on bottom. It doesn't matter. But it does matter where you put this. So we're looking for XY. Do I put it on the top or bottom? Does anyone remember?
Top.
That's right. Why do I put it on the top?
Because the top is small.
There you go. Michaela remembers. That's right. You're going to put XY because that's the side we're looking for. You're putting it on top because it's small. It goes with the small triangle. You want to keep those together. Be it on top or on the bottom, you want to keep them together. So this side correlates with what side, Cecilia? AB. Man.
Question.
Yes.
Why did we XC?
Huh?
Why did you XC?
This side, they gave us the measurement for already. And they also gave us this measurement. Right? No. Do you understand? Huh? Okay, so we're looking for this one right here. We're looking for this side. To be able to find this side, we have to set it up in a proportion. So this ratio, we want to compare the sides that already have numbers. They gave that to us in the book, right? No. Don't just say that. I want to make sure you understand. So I have that side that already has a number over this side that already has a number. Equals, now this ratio, now I can put my missing one here and the one it goes with right here. Now, XZ is 2.5. Now watch, Cecilia. Here we go. 2.5 is XZ, right? Right? And then AC is what, Cecilia? 5. So I'm putting it underneath. See, I'm replacing the letters with the actual numbers now. And then Cecilia, XY is M. And then AB is what? Cecilia.
5%.
Okay, now look what I did. So I have my two sides that they gave us the measurements for already in one ratio, and I'm kind of comparing it to the two sides of the one that we're looking for. Now I can solve, because Cecilia, if I don't have this ratio right here, I won't be able to solve for M. So now I can cross multiply. 5 times M is 5M. And I'm going to be nice. 5.7 times 2.5 is Aiden.
14.25.
Man, I was going to give y'all the answer, but he beat me to it. Okay, so I have 14.25 on one side equals 5M. Now, what do, Emily? I'm dividing both sides by 5 because we're looking for the measurement of that side. And we get M equals, Taylor,
Is it 2.25?
you're close. It's 2.something 5. Gabby, 8.5. So that's terrible. The measurement of M up here is 2.85. So, sit back, look at what we did. No hurry, guys, today, no hurry. I can break this up into 2 days easily, okay? I want to make sure before we go that you understand what we're doing. So, Cecilia and anyone else, if we're dealing with similar figures and we're looking for an angle measurement or a side measurement, just like here, then you want to set it up as a proportional, two fractions with an equal sign. The first fraction, you want to put the given measurements that they gave you with corresponding sides. You don't want like 2.5 and 5.7 in the same fraction. They don't go together. Cecilia, you need to look up here. So you want to get the measurements that they have given you that go together and then set them up equal to what you're looking for and the equivalent, like the large down here. And then cross multiply. And that will get you your missing measurement. Any questions? Now, guys, if you're like sitting there and you're completely lost and you don't want to ask for help because you're embarrassed or you're like, man, she can explain it and explain it and explain it, I still don't get it. Guys, don't just sit there. Ask. I can draw pictures or something like that if I have to. I'll even stack desks and people if I have to until y'all understand.
I volunteered.
See, he volunteers. We'll use him. But guys, don't just sit there and not understand. Okay? Let's do another one.
Example 2.
Example 2.
Yeah.
So, example number 2, same page. Oh, this is ugly. I don't like this one, but we're doing it. Okay, that's a lot of work on there. Okay, so what it said is, if segment BC measures 7.25, find N. Then compare the ratio of the triangle's perimeters to the ratio of their side lengths. Blah, 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 blah. So let's do the first thing that it asks us to do. Let's just find N first. Let me tell you something. I'm being straight with y'all on this. A lot of y'all probably said, okay, I get the first part of these directions. Find the missing side. Okay, I understand that. And then the second part, then compare the ratio of triangles' perimeters to the ratio of their side lengths. Some of y'all, I have now lost you. Let me tell you something. You know what's important? The first part of this problem. That is what is important. The first part of this problem. If you understand what it's asking to find N, you're good to go. Okay? If you're like, what is that other part? Don't worry about it. I'll show you. And then you'll be like, oh, why didn't they just ask it like that? You know what I'm saying? It's kind of like back here, property of proportions, blah, 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 blah. Y'all cross multiply. See what I'm saying? All right, so what I need y'all to understand is the first part of this problem. You get that, you're going to be just fine. So the first thing we're going to do is find N. The second part, basically what they're asking, boys and girls. Now you see why we do these examples together. Then find perimeters. That's basically what they're asking in that blah, 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 blah. So we're going to start with finding N. Because like I said, to pass Algebra 1, to pass Algebra 2, to pass calculus, if you can find N, you're fine. You may have one problem the rest of your whatever years in school. Some of you may take longer than others. You may have one problem that goes along with this, that second part. You will see this more often. Okay? So that's why I want to emphasize. If you can find the missing side or the missing angle, you are good to go. So now I'm going to draw. All right, now y'all better be drawing too. Okay, here we go. Again, I think I drew it too big. Not too bad. And I know it may not look like the book. I do not care. Oh, that's really interesting. Don't y'all like how I talk to myself when I'm drawing and
Yeah.
nobody, oh, I do that every time. Okay. I have X up here, and I'm copying this out of the book on page 106. And this is Z. I have N here. I have 2.85 over here and 2.5 here. Okay, so those are what's been given to us in the book. Does everyone see that? I didn't just come up with 2.85 out of my head. They gave it to us. And then over here, I have A, C, and B. They have 5 here, 5.7 here, and 7.25 there. Okay, I have drawn my similar triangles. Okay. Now, just to humor me, angle X goes with what angle width? A. Aiden, angle Z goes with what angle? Very good. Angle Y, Gabby, goes with angle. Very good. Okay, so do we understand that? Okay, good. All right, so we are looking for side N. Well, the measurement of ZY. Okay, so Cecilia, no, don't get upset. To find a missing measurement in similar figures, what do I have to set up? Okay, it's called a proportion. So we're going to have a fraction equal another fraction, right? Okay, so Cecilia, we have a lot to work with. They gave us a ton of information, unlike the other one. So, which two sides, Cecilia, go together, like correspond together, and we already have the measurements for them?
AB and XY.
Okay, so she said AB first. So, unlike the other one, I'm going to put it on top because she said it first. And then she's correct, XY. I'm going to put on the bottom. So this time my large is on the top and my small is on the bottom. And that is okay to do. You can have small on top and large on bottom, or vice versa. Now, Cecilia, we're looking for the measurement of ZY, correct? Where do I put that, on the top or the bottom? And remember, it's a small triangle. Huh? Well, look up here. You told me AB and XY. So I have large on top, small on bottom. So where should I put ZY? Bottom. We want to keep the smalls together and larges together. So ZY on the bottom. And what side does ZY correlate with? CB. And that's your large. Okay, so that is important. Setting it up is kind of important, right? You set it up wrong, it's going to get you a wrong answer. So notice I have my large on top this time and my smalls on the bottom, but they're together. Does anyone have any questions before we go on? Okay, so now AB is 5.7 and XY is 2.85. CB is 7.25. And then N goes on the bottom. I'll let y'all catch up. Does everyone understand where we got these numbers? Cecilia, do you understand? Okay, so my large is still on top, small on the bottom, large on top, small on the bottom. Now we cross multiply. Yes, ma'am. Oh my goodness.
Unsweet tea.
Taylor, I have a tea. Thank you.
You're welcome.
God,
I was gonna say
caffeine.
sorry. Their sodas are all today, so that
We were literally just
ridiculous.
talking about what we drink for caffeine, and I said I have to have my unsweet tea every day. Thank you.
that.
He brings his tea.
Oh, there you go.
Well, thank you.
You're welcome.
Y'all should thank her because I'll be nicer now. What do y'all say? There you go.
I mean, you were.
Okay. So n times 5.7 is what? And everyone on that side. And then who has 2.85 times 7.25 worked out? Aiden?
20.6625.
Is that what y'all have?
Wait, I'm not done yet.
Tell me again, Aiden.
20.6625.
20.6625.
Can we use calculator for that?
Yes.
Wait, Aiden, what do you have?
I have it written right there.
Oh.
I'll check.
Yep, that's what I got too.
That's what I got too.
Good. Okay. So now I have 5.7n equals 20.6625. Y'all see that? Now we divide both sides by 5.7. And then raise your hand when you get an answer. Taylor?
3.625.
If y'all want to check that out, you can. Okay. Any questions on that? No?
Your cup says line mates for learning. Right
Any questions?
there. What's your favorite color?
Does everyone understand what to do here? And then, so n is 3.625, and they said to find the perimeters. Guys, all you have to do is add them up. That's all you have to do. That's why I said I'm not going to spend time on that, because all you had to do was find the perimeters. Y'all understand? Perimeters, you're just adding them all up.
Does it want two separate perimeters or does it want?
Hold on, Taylor?
For this specific problem, since the smaller triangle is exactly half, you could have added up the perimeter of the bigger triangle and then divided that by 2. You would get the same answer for this specific triangle.
Okay, for this, that's true. That is true. What were you saying?
I'm saying, do they want two separate parameters?
Okay, so
Or do they
the,
want the
to answer that second part of the question, they wanted the perimeter of A, B, C. If you added up the perimeter of A, B, C, 5 plus 5.7 plus 7.25, you would get 17.95. That would be the perimeter for the large, see, P means perimeter of the large triangle. And the perimeter for X, Y, Z is 2.5 plus 2.85 plus 3.625. Now we have the measurements for all three sides of each. And that was 8.975. So we got the two perimeters. They said blah, 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 blah. Then compare the ratio of the triangle's perimeters to the ratio of their lengths. So, ratio, I'm going to do 17, their perimeters. Remember, ratio of their perimeters. There's their perimeters. To a side. So 17.95, that's the large triangle. This is the small triangle. So find some side. I'm going to choose 5 from the large one and 2.5 from the small one because they correspond. So we're comparing the ratio of the perimeters to the ratio of their sides. Any sides as long as they're corresponding. This is my large. This is my small. You do cross multiplication and you get 4.875 on this side and 4.875 on that side. Are they the same?
Yes, ma'am.
So then, yes, they're proportional. And that's the second part of that. That's what they're asking. But I'm telling you, if you understand the first part, that's all you need to know. Any questions on both of those examples? None? Okay, I'll let y'all keep copying. Is everyone done? Or so you still write? Okay, I need to. If you're still writing, keep writing. Okay, so if you're not, then you need to not write. Okay. Let me see real quickly. I want to look at something. Bless you. Okay. I'm going to start on this and then we're going to stop in just a little bit. Okay. I'm going to introduce this. This is, now, so we talked about proportions of similar figures. Okay. Now, I'm going to talk about the second part of this section, scales. Because remember, we're doing 3.3, similar figures and scale models. Now we're going to talk about scale models. Scale is the ratio of the dimensions not dementia, dimensions
Yeah, really.
of the drawing or model to the corresponding dimensions of the actual object.
No match scale.
That's right. So scale is the ratio. Again, we're dealing with ratio. Notice both. We're dealing with lots of ratios of the dimensions of the drawing or model to the corresponding dimensions of the actual object. We're going to do example 5 on page 109. Taylor,
I wonder if you could use.
you can switch it out.
I wonder if you could use this to figure out how enlarged the chip is on like the fridge bag, like Dorito bag, and it says enlarged.
I don't know. All right. Once you have this written down, put your pencil or pen down. Okay. Who remembers what quote formula I used to tell you all the time with model and actual? Anyone? Gabby? Very good. If you can remember this, you will do just fine. Model over actual. Model over actual. Model over actual.
And they. And my day.
Model over actual.
And my day.
Shh. Okay. Let's see. Aiden, please read example 5.
By using the ratio of the sides and perimeter of A, B, C, triangle portion times perimeter of D. Check your work using your answers for exercise 3.
Okay. Did you, this up here, right?
Oh, I was reading the other one.
Example 5.
To make measuring scale model was a 1/8 scale.
1 to 8 scale. Wait. Guys, in your book, see my arrow? 1 to 8 scale. That is important information. 1 to 8 scale. All right, continue.
If the model has the dimensions of
Blah, 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 blah. Keep reading.
17.5 in 10.5 inches times 11.25 inches. We're doing actual dimensions of the tractor.
Okay, so if the model, and I have an arrow there, have all of these dimensions, what is the actual? Do you see I have actual underlined? Model has an arrow, actual is underlined. Do y'all see that? Okay, so what did they give us? Did they give us the model or did they give us the actual? Gabby? They gave us the model. What are they looking for, Emily? They're looking for the actual. That's right. And Michaela, what was the scale that they gave us? 1 to 8. Okay. So they gave us, that's what's important. They gave us a 1 to 8 scale. Okay? The model sizes are 17.5 inches by 11.25 inches by 11.5 inches. And the question is, what is the actual? Okay, so now pay very close attention here. I have students mess this up all the time, so pay very close attention. They gave us how many model sizes, Cecilia? 3. Look, everyone. 1, 2, 3. So how many actual sizes should we have on our paper? 3. They gave us 3 model sizes. Our answer better have 3 actual sizes. Got it? So let's start with the first one. We're going to start with the first one and the model. And I'm going to call it number 1. The first size. Okay, boys and girls, we're setting it up as a proportion. Like Cecilia said, line equals line. Guess what goes in the first ratio? Anyone want to guess? Gabby? That's right. Your scale, boys and girls, goes into the first ratio. Just like that. The scale goes in the first one. The second one, 1/8. So 17.5, does it go on top or bottom? Raise your hand. Thank you, Emily. Does 17.5 go on top or bottom? If you give you a hint, which is it? Let me give you a hint. See this? Model over actual. And this number, is that the model or the actual? There you go. That's your model. It goes on top. We're looking for actual, so I'm going to have an X there. Now we do our infamous cross multiplying.
Infamous?
And I get X equals, and I'm just going to tell you, 140.
Why is it infamous?
Because we do it all the time. Okay, but I'm not done yet. That's the first size for the actual. Now we got to do the second one. Now we're doing the second size. So let's see, Michael, what do I put in my first ratio?
1/8.
That's right. The first one is 1/8, the scale. Michaela, we're doing the second number, 11.25. Do I put on top or bottom? Why?
Because the model goes on top.
Because this is the measurement for the model, and model always goes on top. So then I cross multiply, and I get X equals 90. There's my second number. Now I'm doing my third number. Cecilia, what goes in my first ratio? 1/8, because that is the scale. 11.5, Whit, does that go on top or bottom?
Top.
Because it's the model. I cross multiply. I'm writing fast, y'all can catch up. X equals 92. So then my answer is 140 inches by 90 inches by 92 inches. This is my first number, second, and third. And there's my answer. Are there any questions? Yes.
Isn't this just multiplying everything by
Multiplying everything by what?
8?
Yeah. Well, yeah, because look, we're multiplying 8 times that, 8 times that, 8 times that.
We don't really need to cross multiply.
Oh, yeah, you're setting it up as a proportion. Nice try, buddy. Any questions about this? All right, we're going to pause. This is